gotta stop this now.
Oh, there you
All
go.
right, today we're going to do chapter 3, section 4, solving rational equations and radical equations. Rational equations are fractions. So if you're given a fraction equation like this, you have plus or minus and an equal sign. So whenever you have fractions and equal sign, you want to get rid of the fractions. Get rid of the fractions. That's their whole purpose. The way we do this is first step is find the LCD. The smallest number that 2 and 5 fit into, in this case, is 10. Multiply the LCD to each term. In other words, we have the first term is x over 2. I multiply it by my LCD. The next term is 3 over 5. I multiply that by 10. And the last term is the 4. So basically, I just put everything in parentheses and I put a LCD in front of it. Third step, whenever you have fractions and you multiply, what do you do first? Because this is where high school ruined your brains. A lot of high school teachers say multiply top by top, bottom by bottom.
Yeah.
No, that's the last thing you want to do. The first thing you want to do is reduce. Make the fractions as small as possible before you multiply them together. Because when you reduce right here, that gets you, there's nothing else you have to do at the end. So cancel what you can. The whole purpose, again, the reason this is the LCD, that means I know this one has to fit in both of these. 2 goes into 10 5 times. 5 goes into 10 twice. So this is what we have now after we cancel, after we reduce. It looks a lot easier, doesn't it? Because compared to our original equation, this one looks a lot easier.
Oh,
So what we have to do now is multiply. Get rid of the parentheses. So we have 5x. 2 times 3 is 6. 4 times 10 is 40. And the last step is solve for x. How do we solve for x? Subtract 6 first. Yeah, from both sides.
Mhm.
So we have 5x equals 34. And then divide by 5. Now, I don't know if it'll take this type of answer. This is an improper fraction. So how do we convert from improper to proper? Well, to mixed numbers. How many times does 5 go into 34? 6 times 5 is 30. So we have how many left over? Yeah, but 6 times 5 is 30. 34 minus 30 is 40. Okay. So this is in reality what your answer should be. But I think the computer may take that as an answer because it makes it easier for them to program. So this is the procedure we'll be using in this section. So far, so good. So let's look at our first example. Oh, do you want me to put it back up there? You sure? Okay. The first example is x minus 8 over 3, x minus 3 over 2 equals 0. So we have fractions and we have an equal sign. Do the same thing. What's my LCD? Because it's 3 times 2. What do I do with my LCD? No. Multiply the LCD. You skipped a step.
Yeah.
So we have 6 times x minus 8 over 3 plus 6 x minus 3 over 2 equals 6 times 0. Now we reduce. The 3 goes into 6 twice. The 2 goes into 6 3 times. I got rid of all the fractions. So my fourth step is multiply to get rid of the parentheses. So 2 times x is 2x. Positive times negative is negative. 2 times 8 is 16. Positive, positive. 3 times x. Positive times negative. 3 times 3 is 9. Equals 0. Whenever you get rid of parentheses, what do you always do? Combine like terms, right? And then solve. Very good. So we have 2x plus 3x gives us 5x. Negative 16, negative 9, they're both negatives. 16 plus 9 is 25. Add 25 to both sides. And last step, divide by 5. Actually, there's always a sixth step, CYA. What does CYA stand mean? Stand for? Check your answer. Yeah, so we plug in anywhere C and X, plug in a 5. And see what we get. This is from the original equation. So 5 minus 8 is negative 3. So 8's bigger, it's negative 3 over 3. 3 minus, or 5 minus 3, 2 over 2. Negative 3 over 3, negative 1. Plus 2 over 2 is 1. We get 0 equals 0, so that works. Pretty straightforward. So let's look at an example. We got x squared over x minus 3 equals 9 x minus 3. How would you approach this one? No. So since the denominators are the same, the only way they could be equal is if what? If the top is equal. In other words, if I had x over 5 equals 3 over 5, what does x have to equal? It has to equal 3. So since you have a common denominator.
Okay.
So if the denominators are the same and there is an equal sign between the rational equations, then set the top numbers or top numbers equal to each other. And solve. So if the denominators are the same, and this is what we call a true rational ratio of two numbers. You have one fraction equals another fraction. The only way that could be true is if the tops are the same. If the bottoms are the same, the tops have to be the same. So how do we solve this one? Square root both sides. So we have square root of x squared equals the square root of 9. What does that equal? No. So what happens on the left side? The square root and the square cancel. Square root of 9 is, but it's also going to equal plus or minus. Whenever you take the square root of a squared number, put a plus or minus in front of the answer. Whenever you take the square root of a squared term, then place a plus or minus in front of the answer. Why is that true? Because first off, we look at the degree, the largest exponent. What does that tell us? We have two answers. These are the two answers. In other words, if I put inside there, if I put a positive 3 and I square it, what do I get? 9. If I put a negative 3 inside there and square it, I also get a 9. So that's why when you square root a squared number, you have to put a plus or minus in front of the answer. But, so what's our answer in this equation? We had this equation. Since the denominators are the same, we just set the tops equal and we solve the top. We got this. So is that our answer? No. Because a second thing you have to do is we have to determine which X values can we not use. So are there any X values that we cannot use? In other words, what I'm saying is, are there any, what's the only thing you cannot have in a fraction? Where? Right. You cannot have a zero on the bottom. So any X value that makes the bottom, which we call the denominator, equal to zero, we can't use. So any X value that makes the bottom equal zero of the original equation, we cannot use. So what is our limitation? What X values can we not use? Remember, our equation was x squared over x minus 3 equals 9 over x minus 3. So what limitations do we have? What can x not equal? Any x value that makes the bottom equal to 0. So take the bottom number, set them equal to 0, and solve for it. So we cannot use x equals 3. Because if we put 3 inside there, we get a 0 on the bottom. It's undefined. So what is our final solution? Our final solution is x is negative 3. Let me show you all. This is what we did in the beginning. So since we have the same number on the bottom, same equation on the bottom, all we have to do is check the top. Since x squared equals 9, we took a square root. Because we square rooted a squared term, the answer has to have a plus or minus in front of it, which means our answer could be positive or negative 3. But if we put a positive 3 on the bottom, we get a 0. That doesn't work. So that's why we cannot use the positive 3. So far, so good. I'm going to move. We're right here at 9. All right, so let's look at the next example. Let's go a little bit more difficult. Example 3. If we had 2 over 3x plus 6 plus 1 over x squared minus 4 equals 4 over x minus 2. I always like to put the bottom number, if there are equations in there, I like to put them in parentheses, because you know those have to stay together. Look for the answer. Yeah, I want you to do all those for spring break.
Okay.
The direction is probably-
No.
Okay, so the first thing now we have to do, since we have equations, our first step now is factor each term. So there's nothing we could do on top. Can we do anything on the bottom? Can we factor anything out of that one? Yeah, they both have a 3 in common. Whenever you factor out a number to determine what goes inside there, go back to the original and divide what you factored out. I took out a 3, so the 3's cancel. All I'll have is x. 6 divided by 3 is 2. So that's the first one. How about the second one? Because 4 is made up of 2 times 2, right? So what this really looks like is this, x squared minus 2 squared. It's got a name. It's called the difference of 2 squares. Difference means subtraction. So we have x squared minus 2 squared. The formula is this. If we have two numbers that are squares of are perfect squares, we can factor that out. Because remember, what's missing is a middle number. So we have A and B into both of these things, but the signs are opposite. Whenever you have, these are called conjugates. When you change the sign between them, it's same numbers. What's going to happen is you're going to take the first term minus the second term, and you're done. So this one can factor out into x plus 2, x minus 2, because that's what's under the squares. And then we have 4x minus 2. We also have, while we're doing this, I'll give you the 2 other rules. We have the difference of 2 cubes. Which is a cubed minus b cubed. So in the first parenthesis, it's whatever's under the cubes in here. So it's a minus b. Well, a is the first term, b is the second term. Now, in this longer one, we have the first one squared. The opposite sign of that, and then a times b in the middle, and then plus the last number squared. That's the difference of 2 cubes. Let's look at an example of this one. X cubed minus 8. Right, so this is x cubed minus 2 cubed. So my factoring of this will be x minus 2, because that's what's under the cubes. Then x squared plus 2x plus 2 squared. And that's always the case. So that's the difference of two cubes. We can also have the sum of two cubes. The sum of two cubes means it's a cubed plus b cubed. Okay, notice in this difference of two cubes, since it had a minus, that was the first sign. Then it automatically switches over. And the last one's always positive. So whatever's in the first parentheses, what's in the original. And then this one's the opposite of that. So it's going to be the same thing here then. It's going to be a plus b, because that's what's in there. Then a squared minus ab plus b squared. The only thing that changes are these signs. Whatever's in the parenthesis goes first, and this one's the opposite. Last one's always positive. And here's an example. 8x cubed plus 1. So do we have a sum of two cubes? 8 is made up of what? 2 cubed, x cubed, and 1 can also be cubed. So what we have here is 2x cubed plus 1 cubed. Because once you have it in this form, we can now apply the formula. So whatever's under the cubes goes first. So it's 2x plus 1. The first one, 2x squared, minus these two multiplied together, 2x times 1, and then 1 squared. Yeah, all you have to do is follow what these are. What is A? What is B? A is 2x, B is 1. So A squared, A times B, B squared. And then so what's the final answer? 2x squared is 4x squared minus 2x plus 1. And there's your factor. So that's again, those are the special conditions for factoring, sum and differences. Sorry to take you on a tangent, but I figured that was important. So let's go back to your original equation. What do we do now? You got it? Finish it. So in this one, what do we do now? And this whole thing was because of this in the middle one. I'm sorry. So what do we do now? It's the same 5 steps. LCD. What's the LCD here? Can't be 4. That's a numerator. Least common. We're going to look at the bottom numbers. So let's look at the bottom numbers. There's a 3. There's an x plus 2. and an x minus 2. That's what the LCD is going to be. What do we do with the LCD? Multiply it to each term. So 3x plus 2, x minus 2, 3x plus 2, x minus 2, 3x plus 2, x minus 2. So once you factor out the denominators, figure out what you need for all of them to be the same. This one has a 3, these need a 3. This one has an x plus 2, this one needs an x plus 2. X minus 2, x minus 2. There's one. So those are the only 3 things you need. So they all have the same things. Now what do? We multiply to each term. Now we cancel. The 3 and 3 cancel. X plus 2, x plus 2. So we have 2x minus 2. Here it's x plus 2 cancels x plus 2, x minus 2, x minus 2. So it's 3 times 1. And the x minus 2 cancels. So we have 3x plus 2 times 4. Basically, we get rid of the fractions. Next step, multiply to get rid of the parentheses. So 2 times x is 2x. Positive times negative is negative. 2 times 2 is 4. 3 times 1 is 3. 3 times 4 is 12. We've got 12x plus 2. So we have 12 times x is 12x. Plus 12 times 2 is 24. So now we have this. Whenever you get rid of parentheses, always combine like terms. So we have negative 4 plus 3 makes it negative 1. Any questions so far? Now comes a question. I have to ask you, how do you solve this part? Because we have x's to both sides. We have to have x on one side, don't we? So here, whenever this occurs, here are your steps. If you have x terms on both sides, then what? Always move the smaller x to the larger x. Why do you do that? Exactly. Very good. So you don't get a negative. If we move the 12 to the other side, then we have a negative 10. Negatives tend to hurt grades. So we're going to subtract 2x from both sides. Move the x's first, not the number, other numbers. So 12 minus 2 is 10, x plus 24. Then move the non-x term to the other side. So let's get rid of 24. So we subtract 24 from both sides. They're both negative. 24 plus 1 is 25 equals 10x. She's a tourist. Now, again, it doesn't matter which side of the equal sign the x's are on. But it doesn't matter. You don't want to have negative coefficients. So that's what we have to work on first. Make sure you get away from what you were taught earlier, because they always say move all the x's to the left, everything else to the right. No, that'll make you have negative coefficients. Bad number. Then to get the x by itself, I divide both sides by 10. Now I have x equals negative 25 over 10. So what do I do next? Yeah, reduce. What do they both have in common? 5. 5 goes into 25 how many times? 5 goes into 10 twice. So our answer is x equals negative 5 over 2. Again, I think the computer will take that as an answer, even though it's not really accepted internationally, because you cannot have an improper fraction. The common convention of math says, okay, convert it to a mixed number. So the answer is negative. How many times does 2 go into 5? Twice, with how many left over? 1 over the denominator. So your answer really should be that. But I think the computer will take that number. But we're not done. Are there any x's we cannot use? To figure out what we can't use, go back to the original equation or to where we factored it. Set all of the equations on the bottom equal to 0. So x plus 2 equals 0. This is already taken care of. So x minus 2 equals 0. So the only numbers we cannot use are negative 2 and 2. Those are the only numbers that we cannot use. It'll make the bottom equal to 0. So even though we worked everything out and we get an answer, doesn't mean that that's the right answer, because we also have to look at what can we not have as a final answer. Since it's negative 2.5, we're okay. What's the next example?
Yeah.
Oh, radicals. Now comes work. The reason being because radicals means that we have to do more work to solve them. What are radical equations? Right, radical equations involve square roots or radicals. It could be any root, actually. Remember, this number here is called the root. So if you have a radical in your equation, what do you think we do first? Separate radicals on one side, non-radicals on the other. So we have to slowly peel out everything, so it's only remaining this. So what do we get rid of first? Well, let's do this. So what do we get rid of first? Always get rid of plus minuses first. When you solve equations in algebra, the procedure is always the opposite of the order of operations. Order of operations says do special operations first, then multiplication, then addition. When you solve for them, you get rid of addition subtractions first. I'm not finished writing it.
Like, wait.
I would.
So then we got all the plus and minus is gone. Now we do get rid of anything that's multiplied or divided. How do we get rid of this 2? Divide it by 2, both sides. Now the special operation. How do you get rid of the special operation? Square both sides. So x is equal to 1. And you can always check your answers. We have 2 times square root of 1 plus 3. Does it equal 5? This is the CYA. Try to get used to doing that. Because after we introduce complete the check your answer part, I want to say frustrated when students ask me, I didn't get this right. I made this on the test. Did you check your answers? No. Well, that's why you made that on a test. You should know if an answer is right or wrong before you ever hit enter.
Yeah.
Just by doing this. So what's the square root of 1? Yeah, so it's 1. Multiplication, 2 times 1 is 2. 2 plus 3 is 5. And that equals, so x equals 1 is our solution. Example 4. Three x plus 1 is equal to 4. Is the radical isolated? Yes, nothing around it, nothing behind it, above it, or below it. So that's done. What do we do next? No. We square both sides.
Oh, yeah.
It's already square rooted. So the square and the square root cancel. 4 squared is 16. Now solve for x. Subtract 1 from both sides. And divide by 3. So x is equal to 5. But check your answers. You want to make sure it's the right answer. So 3 times 5 plus 1 is equal to 4. 15 plus 1 is 16. Square root of 16 is 4. So it works. Let me give you another example. Now, this one doesn't have anything in front of it or behind it. Let's look at that first. Got it? Here's another example. Go ahead and work this one out. What did y'all get so far as answers? Not yet? Cool. Well put. Okay, let's look at this. What do you do first? -5. So we have 2x plus 3 equals -2. Then divided by 2. Get rid of the coefficient. Then I'll show you why in a second. So let's say you did square it to get rid of the radical, because this is as far as you can go. But let's say you did square it. So when you square both sides, the radical's gone. 2x plus 3. -1 squared becomes what? 1. Subtract 3. 2x equals -2. Divide by 2. X equals -1. Okay, you got an answer. How do you check if it's right? So plug this back into the original equation. This is the CYA. We have 2 times -1 plus 3 plus 5. Two times -1 is -2. -2 plus 3 is 1, same as 3 minus 2. Square root of 1 is just 1. So it's 2 times 1. Two plus 5 does not equal 3. Again, everything from where I put no solution is stuff you never should have written in the first place. Why? Because what is the graph of the square root function? It looks like this. You cannot have a negative in X, or you cannot have a negative answer in a radical. So in other words, it can never equal something negative. This is where the graph comes into play. So that's, you'd be very, very, very careful about that. Well, when you isolate your radical, if it equals negative, you're done. Don't stop there, because just because it becomes negative and you're not finished on this side yet, doesn't mean it's unsolvable. Right. But what if this was a -2 out in front here? If this was a negative in the coefficient, then that would have changed this one. So very careful about signs. So let's look at example 5. Five plus radical x plus 7 equals x. 6. That's really much fun. All right. How do we solve this one? How would I divide?
Five.
Well, no, because there's a plus there. I have to get rid of that. So I subtract, yes. Actually, I'm glad you said that because that's another thing students, when they look at it, they think it's 5 times instead of 5 plus. So we have radical x plus 7 equals x minus 5. Now what? Yeah, remember, we're trying to get rid of the radical. So because this on the right-hand side is equal an equation, we have to put it in parentheses. Now we have to square both sides. So we have x plus 7 equals x minus 5 times x minus 5. That's what that square means. So in order to solve this, we got to do the foiling of this thing. But didn't we look at the squares, perfect squares of radicals? It's going to be x squared minus 10x plus 25. There's a shortcut. A plus or minus b if it's a square. So let's just look at the plus. That equals a squared plus 2 times ab plus b squared. If it's a minus b and it's squared, then it's a squared minus 2 times ab plus b squared. Where does this 2ab come from? It comes from this. If we had a plus b times a plus b, ab, ab. That's where the 2ab comes from. And it's a times a, b times b. So that's a shortcut. Yeah, if you don't see the shortcut, then FOIL it out. It's not going to hurt. Now what do you do? Move which one where? Well, since this is the x squared, this is a bigger equation. We move this one to the other side. But, okay, here's a corollary. If this was negative, we'd move everything to the other side. Because you want the biggest term to be positive coefficient. So if that was negative, we'd move everything to the left. But since it's positive, we're going to move everything over. So we subtract x from both sides. And we subtract 7 from both sides. So those cancel, which is 0. Negative 10, negative x is negative 11x. 25 is bigger than 7, so the answer is positive. 25 minus 7 is 18. So now how do we solve it? We have to factor it. Remember how to factor? What goes in the first spaces? Yeah. X and x. What about the signs? Look at the second sign. If the second sign's positive, that means both signs are the same. They're whatever the first sign is. So they're both minus. Because if they were both positive, where would the negative come from? From nowhere. So they have to have negatives. So if the second sign's a positive, that means they're the same sign. It's whatever the first sign is. We take the first times the last numbers. So 1 times 18 equals 18. Now we got to figure out what times what equals 18. When we add them, gives us 11. Right. 9 times 2, 9 plus 2. Now what do you do? Anybody? Now what do you do? What are we solving for? X. So we take both of these and set them equal to 0. That is what we call the zero product principle. We have two numbers multiplied to each other that equals 0. So if we had A times B and they equal 0, that means either A is equal to 0, B is equal to 0, or they're both equal to 0. So we set them both equal to 0. So X equals 9 and X equals 2. And eventually, again, whatever's inside the parentheses is always the opposite. So if X minus 9, we know it's positive 9. X minus 2, it's positive 2. We're not done yet. How do we know those are right answers? Check your answers. The original equation was this. We have to try them one for X equals 9 and one for X equals 2 and see if they both work. So it's 9 plus 7. So we get 5, 9 plus 7 is 16. What's the square root of 16? 4. 5 plus 4 is 9. 9 equals 9. So X equals 9 is a solution. Now do the other. Now let's look at X equals 2 as a solution. 2 plus 7 is 9. Square root of 9 is, does 8 equal 2? So that's not a solution. So the only solution we have is X equals 9. We have to be very careful. Always, always, always check your answers. You're getting ready for your spring break. Practice. Oh, no. I'll wait for you if you want to finish. You sure? Or you could take pictures afterwards.
I just read them.
All right. Your notes are very neat. All right, let's do the last example here. Now, what if we had two radicals? Or I should say, if we had more than one radical. The process is still the same. Rest of those examples. The process is still the same. Here are the steps. Isolate one radical. You have to get one radical by itself on one side. So which one are you going to move to the other side? And it really doesn't matter which one you move, because if there's a solution, it'll work no matter which one you move over. You want to move the first one or the second one over? Okay. Then how do we move it over? They're added together. So subtract. I have to subtract by the radical of x minus 3 from both sides. So the radical x minus 3 disappears. So we have radical x plus 5 is equal to 4 minus radical x minus 3. We subtract it. Now what do? We have to get rid of the radical. Square both sides. So I square that side and I square that side. Remember, it helps if you put parentheses around them because you're squaring, they're both equations. You don't square both of these separately. This is one equation. You have to square them together. So in the left side, the radical disappears. On the right side, we have 4 minus radical x minus 3 times 4 minus radical x minus 3. So we have to FOIL this. 4 times 4 is 16. Positive times negative is negative. 4 times radical that, so it's 4 radical x minus 3. That's to take care of the first term. Now the second term, negative that. So it's negative 4 radical x minus 3. Negative and negative makes it a positive. Radical x minus 3, radical x minus 3 is radical x minus 3 squared. Simplify. We have 16. Negative 4, that makes it negative 8 radical x minus 3. The radical and the square disappear, so we have x minus 3. Now we're only down to one radical. So we got rid of all this stuff, combine like terms on the right-hand side first. So we have 16 minus 3 is 13. Plus x minus 8 radical x minus 3. So far, so good. Now what do you do? Yeah, isolate the radical again. So we gotta move everything else to the other side. What I would go ahead. Let's get rid of 13 first. So subtract 13 and subtract the x. Those two disappear. We have a negative 13 minus 5 is 8 equals negative 8 x minus 3. Never divide by negative. Change the signs. And I know when you do this on your own, you're going to divide by negative 8. I know you've been taught most of your life doing that. Now we have to get rid of the coefficient. So we divide by 8 both sides. Now what do you do? Square both sides. 1 equals x minus 3. So what does x equal? All right, so we add 3 to both sides. X equals 4. But does it equal 4? We don't know yet. How do we test it? We got plug it back into the original equation. I'll leave that there for y'all. Wait for Caitlin to finish writing. I know she's still writing, but she didn't. Yeah, because we have x minus 3, so we had to add 3 to both sides. You are very welcome. So what we do from here is now we have to CYA. Square root of x minus 3 plus the square root of x plus 5 equals 4. We're saying that x equals 4. So 4 minus 3, 4 plus 5. 4 minus 3 is 1. 4 plus 5 is 9. Square root of 1 is 1. Square root of 9 is 3. So x equals 4 is our solution. And that's all there is to it. Remember, you have to have all these done by next week. No, I just had them in there in case we had extra time. We said, I'd ask y'all pick some in there. Yes, sir. What's that? Oh, yeah. There you go. That was section, here you go. All right, that does it for the week. For the first half of the